I've got another example. We're trying to solve this maximization problem using the simplex method. And our variables are x, y, s, t, and f. And there's our matrix. It's 4, 1, 0, 1, 0, 5, 17, 4, 1, 0, 0, 60, negative 3, negative 4, 0, 0, 1, 0 for our objective function there in the bottom row. All right, so we look for the largest negative in the bottom row. That would be the negative 4. And so that identifies our pivot column as the y column again. And then to do our pivot row, I want to take the values in our last augmented thing here and divide them by the numbers that are in the corresponding location. So I'm going to take 5 and divide it by 1, and I get 5. And 60 divided by 4 gives me 15. And so I want to take the smaller of those two. So my top row becomes my pivot row. And I've got a nice 1 there to work with for my pivot. That's great. Now what I want to do is create zeros below that. And I have to use the pivot. So you might look and say, well, I can add row 2 and row 3 together to create a 0, but that's not using my pivot. And if I do that, it's going to throw off my answer. To do the simplex method, you have to use your pivot row to get the zeros. So I'm going to take negative 4 times row 1, add it to row 2, put it into row 2 spot. That should give me a 0. Negative 4 times 1 plus 4 gives me 0. And the other operation I'm going to do is 4 times row 1, add it to row 3, and put it into row 3. Those two operations should give me zeros below the 1 there in that first row, second column. So let me copy down the first row. And then let's do this first operation. Negative 4 times what's in row 1, add it to what's in row 2. So negative 4 times 4 is a negative 16. Add it to 17, I'm going to get 1. Negative 4 times 1 plus 4 gives me 0. Negative 4 times 0 plus 1 gives me 1. Negative 4 times 1 plus 0 is going to give me negative 4. Negative 4 times 0 plus 0 stays 0. Negative 4 times 5 is a negative 20. And I want to add that to the 60. So negative 20 plus 60 gives me 20. Oops, 40. 20 minus 60, or 60 minus 20 is 40. All right. And then for the bottom row, I want to do 4 times what's in row 1 and add it to row 3. So 4 times 4 is 16. 16 plus negative 3 is a positive 13. 4 times 1 is 4, plus negative 4 gives you 0. 4 times 0 plus 0 gives you 0. 4 times 1 plus 0 gives us 4. 4 times 0 plus 1 gives us 1. And 4 times 5 is 20, plus 0 is 20. And all my values in the bottom row are positive, so I'm at the ideal solution. The x column that I look at here is really messy. It's got all kinds of numbers in it. So I'm going to set x equal to 0. The y column is a very pretty value. It's got the 1, 0, 0 matrix part of it in there. And the y corresponds to 5, so my equation would be y equals 5. The s column here is another nice column, and the 1 corresponds to 40, so s is equal to 40. T column is all messy, so I'm going to let t to be 0. And my f column, your f column should always look like 0, 0, 1 all the way through your calculations. It should not change if you've done everything correctly. And the 1 corresponds to the 20, so f equals 20. So that would be my ideal solution. X is 0, y is 50, s is 40, t is 0, and f is equal to 20. So that means I've got whatever s is. S is our slack in the second equation here. our slack variable, whatever that quantity represents, is I've got a lot extra of it that I don't need. I'm really limited by the 5 of whatever it is I have available in the first constraint there. All right, that should do it.